Hello. To calculate the one side hand. This is probably the simplest test we've looked at, and part of the reason why it's simple is because it's from a family of t-tests. So we've already looked at how to calculate the paired sample t-test, which is very similar logic to this. So I'd highly recommend watching that video if you haven't already. So what is the one sample t-test for? Well, it's for testing whether the mean of a group of scores differs from a specified value. So if we have a mean that we know that would be usual for a group, and we want to test another group of scores against it to see if it's significantly different from what we're expecting. That's what it's normally used for. So I've got an example here where we're looking at IQ in a population, and if you know anything about IQ, the mean of IQ is always 100. So that's the value that we want to test against to see if a population has a higher or lower IQ than average. We've got some scores here that we're going to test to see if this particular group of people on average has a higher than average IQ. So just like in previous videos, we've calculated the mean and the standard deviation of this group of scores. The standard deviation is the square root of the variance, and I've shown how to calculate the standard deviation in previous videos. I'll put a link to that here. The mean is just all scores divided by the number of scores. So in this case, we will just add up all our scores and divide by 5. To calculate the one sample t-test, the first thing we need to do is calculate the difference between this mean and the mean we'd expect. So I said that the mean of IQ is usually 100. So that's what I want to test against to see if they're better than normal. So if we look at that, we take 106 minus the value that we'd expect, and we get a difference of 6.4. So there is some difference, but we know from previous videos that the t-statistic has two components. Basically, what we can explain and what we can't explain. So there's always going to be some error in estimation. All those scores in our group aren't the same score, so there must be something else explaining some of the variance in our scores. So to represent that, we have two components in the t-statistic. The difference between our means, which is the difference we want to look at, and then an estimate of the standard error, which basically gives us a difference that's adjusted for the amount of uncertainty in our estimates. So how do we calculate both of those two things? Well, the difference is the difference we've already calculated. The estimate of the standard error is we've calculated previously in the past, but in our second group we have no error because we're comparing it against one value. So the standard error estimate only needs to take into account the one group, because that's the only group where there's any variance in scores. So the formula for the standard error of the difference is the standard deviation divided by the square root of the sample size. So if we apply that in this case, we had 5 scores,